Okay, so the 1-2A worksheet that we see here, let's talk about the instructions, because there's one extra little piece, well, a few extra little pieces. It says state the domain and range, tell if it's a function, yes or no, and if the graph is a function, tell whether it is discrete, continuous, or neither. And we didn't really talk about that too much, so I want to talk about that part of the instruction. So let's take a look at number 1. Okay, so the first thing that you would do for domain is think about what x values that the math bug could stand on. Okay, so the math bug can stand on an x value of -3. Then he would leap over to an x value of 2. So it's a weird one as far as how you write that. So he can only stand on 2 x values. So the domain, the way you do that, it's kind of a weird way to do that, is you say he could stand at -3 and only -3. So you just keep it as your beginning and your ending. Or, so that's your or thing, he could stand at +2 and only +2. So that's how you would write that for number 1. Let's talk about range though. Range what y values he can get to. This arrow indicates that he can get down as low as he wants, and the math bug's starting up. And then he's at a +2, and he can leap over here, and he can keep going. So the range is a weird one. The domain were only those 2 points, -3 and 2, but the range is all real numbers. He never has to skip any y value along the number line. Is it a function? Does it pass the vertical line test? Well, a vertical line cannot hit it in more than one spot. This vertical line hits it in 1,000,000 spots. This vertical line hits it in 1,000,000 spots. So we would say no, it's not a function. Now, I want to do one that is a function, and then I want to answer the question, is it a discrete function or a continuous function? We'll do one of each. Any questions about number 1?
You go back to it really fast.
No, keep there. There's number 1. Do we have any questions about number 1?
Is that -2 and 2 or just regular?
Just 2 and 2. Yeah, so -3 to -3 means I only use -3. 2 to 2 means I only use 2. I've even seen it where you just kind of put that number in a bracket. I'll accept either way, it doesn't matter. But usually an interval shows you the starting spot and the stopping spot. So if I'm only at -3, I'm at -3 and -3. Okay, everybody good with number 1?
Yep.
Okay, now let's jump to number 2. Again, I want to talk about discrete, continuous, or neither. Let's talk about this one. Okay, think about the math bug going from left to right. That's domain. What x values. He can't stand at -5. He can almost stand at -5, right? And then he would be walking, and he can get all those x values and all those x values and all those x values. So what is the starting place for the domain? Almost what number? Almost -5. So we say that by putting that in a parenthesis. What is the highest x value he can get to? 5. But can he stand there?
Yes.
Put it in a bracket. Okay. Now let's talk about range. What is the lowest x value, lowest y value, because we're going to the bottom to the top. What is the lowest x value that he can stand at?
-2.
Is there somewhere, anywhere, that's closed in that he can stand?
Right there.
Yeah, right there. And anywhere right here, yeah. Okay, so now he's trying to get to the top of the graph. Does he get to all of the values up to what number? 2. Yes, he gets to every single value up to 2. So our range would be from -2 to +2. What's interesting about range, even though there's one spot that has an open circle, as long as there's a different spot that colors it in, that's all that matters for range. That's going to happen. It can't happen for a function's domain, but it could happen for range. Now let's talk about is it a function?
Yeah.
Yeah, see the vertical line test? Vertical lines only ever hit it once. That's a yes. Now, is it discrete or continuous? A discrete function, you can count the number of things that are in it. A continuous function, it has an infinite number of things. There's too many to count. That's the way that I think about it. Discrete means there's a point, 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 point. I can count there's 5 points. Continuous means it is some interval along the x or y axis. It is lots and lots of points and all the points in between. If we think about this function and we think about how many points there are along this path, let's just think between 1 and 2. There's 1, 1.1, 1.11, 1.111, 1.1111, 1.112, 1.2, 1.7, there's an infinite number of points just in that little section. So this is continuous because there's too many points to count. So if it is a chunk of, and look at our domain, it is every single point between -5 and 5, including +5. So that's a continuous function. If you could start drawing it with your pencil and never lift your pencil, you have just colored in an infinite number of points, okay? So that's continuous. Let's go to 5. Let's go to 5. The domain, okay? I'm going to list the points. So this is -3, 1. This is -2, 0. This is 1, 4. This is 2, -5. This is 5, 1. Okay? First, let's go to domain. Domain is the set of x values we used along the way. When it is a set like that, we can't use interval notation. You just put a little bracket and you list them, -3, -2, 1, 2, and 5, were the x values that the bug would have to jump to the next one and jump to the next one and jump to the next one. Range are the y values that he jumped at. If it's repeated, you don't need to write it. It's just what are the sample of the y values he can use. Can somebody tell me what's the range? What are the y values he jumped at?
See the numbers. 1, 1, 4, 1, 5, -5. Wait, is that a 1?
That's a 0.
Oh, 0.
Yeah. 1, 0, -5, and 4. If a number repeats, see how the 1 repeated? In a range, you just list them, so you don't have to list them all. So the range would be the y values, -5, 0, 1, and 4. It is a function when we see that all of the x values are different. Now, the y values are allowed to repeat as many times as they want. But are all the x values different? Are all the x values different? Yeah. None of them line up vertically. None of them line up vertically. They're all not the same. Also, there are 1, 2, 3, 4, 5 points. There's 5 different things in our domain. That's another way to check. So yes, it's a function. I said there were 5 points. I can count the number of things in my domain. So this is discrete. So that's the difference between discrete and continuous. 2, they're all connected with little line segments or, I never have to lift up my pencil. If the math bug's here, I have to lift up my pencil to get to the next point, to the next point, to the next point, and so on. So discrete is a countable set. Continuous is not. It's so many points you can't even count. See the difference? Okay. So are there any ones you look at that you go, I would like you to do one more? Pick one more on the page you'd like me to do. 7. Okay. The domain of a circle are any x values from here to here. Now you can get to those x values by going to the top of the circle, or you can get on those x values to go to the bottom of the circle. It doesn't matter. That's your domain. So let's assume it hits perfectly at -2 and 2. So the domain would be from -2 to 2. The range. what is the lowest value and the highest value? What is the lowest value for this circle?
Make 1.
What is the highest y value for this circle? So that's your range from 1 to 5. We assume they didn't they made a smooth curve around it. So 1 and 5 are included. Think about the vertical line test. Is it a function?
Yes. No.
No, you're right, because that vertical line hits it twice in lots of different locations. These two are lined up. These two are lined up. If you're in a calculus class, sometimes they'll use half the circle so that like the top half or the bottom half to avoid that. But no, it's not a function. If it were a function, it would be continuous because it is a smooth curve. You wouldn't lift your pencil to draw it. But in this case, there's too many places where there's a repeat. Okay? So your job is to work on this. Hopefully get it done before you walk away. There you go.
I use the restroom with that.
Yeah.